Yeah, it starts recording. Hello, everyone. I want to welcome all of you to the structure webinar. I'm going to thank you on behalf of your future clients for taking the time out of your schedule today to talk shop a little bit and to learn more about a house. So I'm Melanie from HomePro, the home inspection company, and we are going to be able to talk to Rael today. Rael is going to share his knowledge, which spans more years than probably he cares to tell you about. So he was a GC for I think about 30 years, and then he inspected for about 15 years, and that was all just immediately after birth, as you can see. So thanks for coming today. We will record this class and send it out to you, and we will stay after to answer all of your questions. So Rael has about 30 minutes of topic for us on the structure of a house, and following that, he'll stick around to answer your questions. I'll turn it over to you, Rael.
Thanks, Melanie, and welcome everybody. We were just thinking about right off the bat.
We can't hear you.
You can't hear me? I'm not muted.
I can hear you. I can hear you, Rael.
Okay. Hoping everybody else can, or else this might be a little strange. So you're thinking about original structures. Whenever I used to see movies from the West where the pioneers are going out and building houses with trees, they basically had a floor that was dirt. But when you got into the towns, even back in the West, you were in the towns and they had all kinds of dance halls and homes there, hotels and things, stores, but they were raised up out of the dirt. So there was something of what we would know today as perhaps a crawl space. Also, perhaps in the dirt, they might have had a root cellar where they would store some food and things. But in modern structure, what we're looking at today is a lot of homes that are being built on a slab. So we're talking about just a plain concrete slab. Everything would have been set up beforehand with the proper preparation of gravel and plastic barriers below. What we're seeing here is the slab. Of course, also the plumbing supply and the plumbing waste lines would have been installed below in the dirt. And this is what we'd be looking at as a fresh, basically slab to build on. Okay, from here we go into cement block foundation, and this was common for many years and is still used today. We always just need to bear in mind that the actual construction process and the viability of these buildings and structures are dependent upon who's doing the building and the installation. So it's really important to have qualified folks doing all of this. Now, just mentioning this cement block foundation or masonry block foundation, we're looking at a product that's basically two holes that's surrounded by about an inch or so of cement, and they're stacked one on top of the other with some mortar in between as the cement to the base to hold them together. But this product is not impervious to water. It'll hold back some, but it is actually a porous type of material. So water does penetrate through it. So the whole thing here about this type of structure is that the outside walls of that we see right here should have some foundation coating and perhaps a drainage system around it to move water away. And as we can see here on the sides to the left and right in the front here, we're below grade quite a bit. And being that we're below grade and water runoff will be coming up to the home in form of regular groundwater from the way the slope is around the home, as well as the gutters from the structure dumping the water out near the foundation. That's why we always recommend for an extension on the bottom of the downspout, the bottom boot, to actually extend it about 6 feet away from the home to get that water away from the foundation, because we don't want it to actually seep its way through. When it does go through into the basement, it causes an issue with buildup of mold and mildew, and then it tends to get into the structure of the woodwork on the framework as well. So you can see right here in the top, what we call the cap of the foundation, we've got some pieces of metal that are sticking up in here. Usually they're going to be rebar coming through here, and the bottom sill plate, as we'll see in a later slide, bottom sill plate sits on top of this wall right here with the actual metal sticking through. It's usually threaded, and then once that bottom sill plate is set here, there's a washer and a bolt that would be attached and snugged on down on top of that to hold that bottom plate there in place for our stud wall structure to be built above it. The next thing we came along with was the poured concrete foundation wall. And this pretty much is a wall that would hold back any water on the exterior. As you can see here, we've got gravel sitting up on this pile. There's gravel underneath here. We're going to actually have the formation of a drainage system on the outside, even though we are solid poured concrete. And the reason why we have this is because even with a solid poured concrete, sometimes they shift and sometimes they crack, and then because they do that, they will leak, and we'll see that in just a moment. So nothing is perfect, and again, it depends on how it's installed. Sometimes it's just a simple matter of there's a weak spot within a poured foundation because perhaps it was done in the heat of the summer, and the truck arrives with that big barrel on the top, and it only carries a certain amount of concrete. Usually they determine it as 10 yards of concrete. They pour it on in there, and then they have to go back and get a second load. You would think that perhaps they would have two trucks, one about to leave the plant as we're getting finished with the first, but that's not usually the way it works on a small residential pour. So the truck would leave, it would go back to the cement manufacturing plant, load up again and come back, and you might have an hour or two before the truck gets back to continue pouring this foundation. And the result would be that for an hour already in 90-degree heat, the concrete has already started to cure and harden. And when you come back in and you pour in your second pour, there's likely to be a weak spot at that actual connection because it wasn't all one single pour, but two separate pours. So here we're looking at a finished poured concrete foundation, and this right here is a great indication of what I'm talking about, where they were pouring the foundation, they ran out of concrete on the truck, and now they had to come back with a second pour, and you can actually see the demarcation line here where the actual second pour connected with the first. And so there is a little spot where you can see it's darkened, and we're looking at possible moisture being able to penetrate through this area. So we would keep an eye on that. This obviously is an inspection process that's taking place from the ground up. Now, bear in mind, when you're dealing with inspections from the county or the city, think about what their process is. Their process is involving them to do maybe 15 or 20 homes in a day. How much time can they actually spend on the project? If they have travel time, leave their office at say 9 in the morning, have to be back by 4:30 in the afternoon, maybe some time for lunch and travel. So, they don't have a whole lot of time to be on the actual project. That's why it's always a good idea if you have clients that are on doing a new build, not necessarily just to do an inspection once the build is complete, but let them also consider a phase-by-phase inspection that we at HomeProbe do. Moving on from there, we would have, again, on the exterior, the waterproofing done with the foundation coating and a drainage around as well, and that would be great. So here what we're looking at is what we just described about the two pours. And there was a weak spot. If you look carefully, there's actually a ridge right through here or a space that had been cemented up. This is a vinyl patch that's been put onto this wall where the separation or the small crack was, and they had some water leaking. As a matter of fact, if we look at this particular slide on the left and on the right, we see not only the darkened spot right here, which is moisture on the wall, but this white stuff here. And this white stuff is called efflorescence. That efflorescence shows us that there's actually a chemical reaction taking place and that we're seeing moisture in this area behind the repair that was done. So these bubbles that you see right here are actually moisture that is forcing itself up against the back of this repair that was done. So this would need to be addressed and taken care of. So we're looking at a couple of different methods of doing this. We can have an injection. If the crack is wide enough, they can actually do an injection of the vinyl patch or epoxy, polyurethane that's actually injected into that crack to seal it on up. If the landscaping hadn't been completed yet, then it would be an opportunity to kind of dig it back out on the exterior and actually make sure that there was a screening or perhaps a polyethylene, a plastic barrier put over the area to help as well with any penetration that was going through that crack. So here we are, we see that epoxy and polyurethane injection that actually can be done into the wall, which works out very well. So yeah, after we started getting out of the dirt floors, we're raising our floors up, we would look and into the crawl spaces we would go. You know, even on outside walls to support the home, there might have been either a brick column or a cement block column, as you see right here, with a wood blocking that's put in or shims to make sure that our beams were properly supported. It needed to have a proper foundation footing dug under each of these to make sure that the area was supported well. When we had openings underneath the home, so in other words, there wasn't a complete foundation, there would be these brick columns that would be built on the outside walls with fresh air traveling through. But eventually we started enclosing them using brick, using wood, using siding, basically keep the critters out from underneath there. And also, you know, with the advent of heating systems such as floor furnaces, which was the original heating type system, we needed to be able to drop that into the level with the floor on the inside of the home, and the actual burners and everything was below the floor, so we needed to get into the crawl space for that. This is a good application here for a crawl space. You can see they have a plastic vapor barrier down, which is a requirement. We actually have insulation up top here. We can see the pink stuff. That's what we want to see. We would not want to see the paper backing that's on there. That's actually a vapor barrier, and that vapor barrier should be towards the underneath of the home to the heated space side. So this is exactly done the way it should be, and it's done correctly. When there's water intrusion in our crawl spaces or in our basement areas, you can see we have dirt. They've put some gravel into this area to try to slow it down, but you can see the moisture was down there and it's come through. And you see what's happened here with this particular pier. The area had been washed away around that pier, and then the actual support pier had collapsed in this particular situation. So here we're looking at, okay, we've got an older home and we've got the floors that are not level. And if you're going to go in and do renovation on the top end, let's make sure that our floors are level before we do that, because after the fact, not only is it more difficult, but you are going to cause some structural issues on the inside. If you've gone ahead and replaced your kitchen or bathroom with ceramic tile products, as soon as you start jacking up that floor, you are going to seriously damage those products that are in those areas, as well as perhaps new floors that have gone in are likely to buckle. So here we see these two guys have a hydraulic jack right there. This is a main beam that's running across the whole length of the foundation, and they're measuring and they're seeing that everything is actually going up to the spot that it should be. And then they would come in and they would put in a permanent support, either again with masonry or with a steel column with a proper foundation to it. So here we're seeing some of that in a much older home, where we see these brick piers that are back there, and we've also got our steel columns in place, and they've actually dug out and they've put a foundation in there, also some gravel. All we would need here to finish out the project correctly would be a nice plastic vapor barrier. This is my favorite support for underneath the floor. So for those folks who think about Rubbermaid, what a wonderful product this is. It's actually holding up the area underneath the kitchen that was redone. It's kind of funny how when contractors come in and they do some renovation to a home, they don't kind of think about maybe these folks might get an inspection, and or maybe they wouldn't, and if they didn't, nobody would come in and see what we did to support this. So this happened to be a bathroom renovation that was done. The shower pan had been leaking, and they took out the shower pan, they fixed everything from the top, but now they needed support for whatever they had done from below. And this is what they did. Instead of putting in a proper beam, another support with masonry perhaps, or steel, and securing that correctly. This is not the way it's done, but we do kind of get a chuckle when we see stuff like this, sort of a shake of the head, take a picture, let the client know this is what's going on, and let the people who did the renovation come back in and correct it. So let's look at some engineered stuff. You know, this is the way the market has been going. This is the way construction is being done these days. We have different types of structure. We'll see in just a moment what was original, which was what we call a stick frame, which is individual lumber. And here we have the engineered floor joist. So with an engineered floor joist, if you're thinking back to the homes that were built in the 50s and 60s, the rooms were somewhat smaller. You know, 14 by 12 would already be considered a fairly large bedroom, because it needed to be supported through the bottom with extra piers or steel columns and beams if the rooms were larger. And when we came up with engineered floor joists, you can actually see the size of these rooms is fairly large now. And we don't have that bouncing going on or that squeaking going on that we would have with regular 2x8, 2x10, or 2x12 floor joists anymore. Fact is that, you know, new wood, green wood that's there, it's gonna, you know, still need its time. Back in the day when they were using stick structure and floor joists, etc., they were using green wood that was kiln dried. So the wood was actually dried before it came in. Nowadays, when the trees are and the joists are made, it could be green wood, not dried sufficiently, and so they would tend to buckle, to bow, to bend, and it's not as good as an engineered floor joist. So they actually, you know, did a good thing when they came up with this engineered floor joist, and it's basically called an engineered eye floor joist. It has this piece of lumber at the top right here, some wafer board between, and then another one below, and that is extremely strong and can be made to any height or thickness to accommodate the load that's going to be going on top of these particular type of floor joists. This is what we're talking about when we're dealing with stick framing. So here we're looking at a 2x8 or 2x10 floor joist, and we have our blocking that's going on in between, which stops the actual floor joist from curling in or out. It keeps it good and straight. And you can see it's about halfway distant for the length of the thing, and the same in the back right here. They probably add some more in between over here as well, depending on the length of the floor joist itself. What this individual is doing is actually applying a structural glue that's going to be put on top of these rafters right here, and then they're going to lay the plywood or the wafer board or the oriented strand board sheathing on top of this on top of these floor joists to hold them down. So when you have a home that was built 20 some years ago and all of a sudden your floors are starting to squeak underneath that carpet you've got down there, it's because now the glue is dried out, and with time it's that plywood is now a little bit loose, and we're hearing that plywood is being you know, raised up and pushed down as we walk across it, which is causing the squeak. Unfortunately, the only way to fix that is to roll back our carpet and our pad and to put some screws down in there to reattach it to the floor joist, which could be somewhat time consuming and expensive. So here's what we're looking at, a basic structure. Double plates on the bottom for a second floor, our band joist, which goes all around. We got our bottom sill plate, and then we start our stud structure going up from there. Then we have our subflooring that sits on top of that joist. So here we have a look at just a regular, here we are, our plywood floor, our bottom joist, and our wood stud structure. Over here we have our headers that go over the doorway, because this structure is set at 16 inches on center, which is the standard for a wall construct. And being that we have it missing over a door, which could be a 30-inch door, a 24-inch door, a 36-inch door on the interior, we need a header or a lintel to carry the weight over that doorway. So you see that's in place, which is great. And then now we're going up to one floor above this. So this would be perhaps a third story. And they've got in here an engineered truss, which we will show in just a moment. Here's what it looks like from above. So these are built out at a factory that makes these particular types of trusses. We're always looking on an inspection. So imagine we would have to check every single one of these to make sure that these plates are in place. And sometimes they're missing. Sometimes things get broken when they're actually installed, but this is what we're looking for. We're looking for all of these structural plates to be in place, which make this thing a viable structural component. So this is a close-up view of what we're talking about, where all the pieces need to be secured together. Here's something on a brand new construction where somebody decided to move the actual air vent from where it was originally. And so now we have the whole floor system. You can see there are 4 pieces of floor joists right here with plywood in between. So this is carrying some major weight, and they've decided that it would be okay just to put one piece of 2x4 in there to hold up the whole floor system right there. So here we can see the vent was changed in the plans, and this main support beam is resting on one little piece of 2x4, which we would of course report and have it taken care of, and just had passed the local municipal code and inspection. In all the years that I was doing inspections, I never did find, when I was out there, a county inspector that actually went in and crawled into a crawl space. Maybe it was just my bad luck that I never found one, but not for much. Also, when we install steel columns, in this particular case, we should have had that column 90 degrees turned. These little flaps they put on there later is of no consequence at all. This should have been rotated 90 degrees so that this big plate right here would have covered all 4 of those joists right there. Okay. Exterior wafer board is part of the structure as well. Many years ago, they used to use what was called a gypsum board, which is a very soft type of material, not at all as hard as what we have now with our wafer board. Could have been plywood as well. And this would be nailed to the studs, and this would be given the rigidity that we needed on the exterior of the home. This is a good look at the roof truss framing. Same idea as the floor truss. Make sure that all these plates were in place. This is our stick framing, where you can see the old school rafters itself and the center board, and then of course our ceiling joist down here. That's how that was done. Here's in new construction in the attic, where this is a truss. It was broken. It was never found by the county inspector, but we found it in our inspection, and this would need to be repaired and signed off by a qualified structural engineer, because that is an engineered product. House wrap. So, house wrap is pretty much what we would find and called for now in most homes. This is what it looks like. This is called Tyvek, and it was installed to improve the insulation as well as limit the amount of moisture passing through the exterior walls. The older homes had felt or roofing tar paper installed, and this was developed back in 1963 by DuPont. It was actually became a code requirement in 2003. This is what we're looking at basically here, the way the house wrap is applied to the exterior of the home before the siding was actually put on. About brick veneer walls. Giving you an idea of how this was done. We had our framing, we have our sheathing back here, and then we had our sheathing paper, our house wrap. There'd be about an inch gap between the brick and the sheathing. And then we would have, and we always look for the little weep holes in the brick courses near the base. Simply, if there was any moisture that was in behind there, it would have a way to exit before it got to the foundation. And of course, along the bottom of the foundation, we would have our flashing. Some of the areas that we would see, some of this sort of stair-step crack, this had obviously been repaired a couple of times before, so it's an ongoing issue. A lot of times we'd find these at the corners of the home where the downspouts are actually emptied out and we're washing away parts of the foundation. So this would be something, if you're showing your home and you're seeing a lot of this with pretty wide gaps as you see here, perhaps it would be a good idea to go ahead and consult with a structural engineer prior to actually getting the home inspection done. Because if it's a home inspection that's done and called out, then you're going to have to pay for the structural engineer to come out and give you the scope of what it would take to repair that. Whereas if the structural engineer came up and said, well, hey, it's going to cost you X amount of $1,000 to repair, your client might not want to move forward with that particular home and look at something else. Just mentioning a couple of the other surfaces that are around. We would see our scalloped edge here on the siding, which would identify it as asbestos siding. There's no need to necessarily remove all of the siding. You can encapsulate by going over the top of it with another set of sheathing and then attach your siding to that. That involves, you don't have to get all kinds of hazmat and special materials and special places to go and dump the stuff, which can be highly expensive. You have a way to encapsulate by covering it. Bear in mind that behind this, you do have your sheathing, also your tar paper from this age, and you would also have your insulation and your plaster or drywall on the interior. So there wouldn't be much chance of you having an issue with any of the fibers going through here into the interior of the home. Metal siding and vinyl siding. Metal, of course, was early construction, steel, and then we had aluminum. The only thing about those two products is that it would dent if you're playing baseball or something out in the yard and you got a dent in it, you couldn't repair that. The dent was there for good. Then you had vinyl siding, also good siding to have. And the actual fact is with the steel siding, if you scratched the surface, you would see the steel siding or the metal siding, the silver would be showing through. But vinyl has a color going all the way through, and so it didn't reveal a different color from underneath. Again, the issue would be about how it is installed. There would always need to be this, you see this ½ overlapping gap here. The nails couldn't be nailed up too tight because that would stop the expansion that would be taking place on a heated day. If it wasn't done correctly, this is what would happen. There would be a bulge because of the expansion in the actual vinyl itself. Fiber cement siding, great product. Do we caulk? Do we not caulk? The original, when it was installed, there wasn't any house wrap. So those days you would need to install caulking, but today it's not required anymore because of the house wrap. All right, and then there's, of course, what we call the good stucco and the bad stucco, right? So let's deal with the synthetic stucco first. This was always known as the bad stucco. Well, when I heard about this stuff and I was building my own home, I wanted in, simply because I'd heard that it had great insulation capability and it didn't crack like hard coat stucco does. We'll cover the hard coat in just a moment. The difference being that here we have our sheathing on our EIFS, and then you can see this very large insulation foam right here. There would be a washer and a fastener that would attach it to the sheathing right here. You would have a fiberglass mesh that would be here instead of a metal mesh that you'd have on regular stucco. You have a base coat and then a finish coat. So just 2 coats on top of that. For me, it's worked out great. Really happy with the product over all of the years. Then we have the regular hard coat stucco, which is a 3-coat process where again you see the waterproof, the house wrap, building paper, metal lath instead of the fiberglass. And then you had 3 coats of stucco put on there. Also that metal screed on the bottom, which would be actually required in both of the applications. So yeah, I mean, drive up to the house as an inspector and you would see the cracks from the street. So you knew you would have hard coat stucco. You wouldn't necessarily have to go banging on it to see where it was. If you walked around the house, eventually you would see evidence of either the crack itself or one that had just recently been sealed up. So both the hard coat stucco and the EAFS, they have maintenance and installation requirements that need to be followed in order to have a trouble-free ongoing protective product. So we need to maintain at least 6 inches clearance between the bottom of the product to the soil level. We need to maintain our caulking around the windows, the doors, and the termination points, such as the fascia boards. Installation of flashing around doors as well as the kick-out flashing in the gutters are critical. So we'll just look at a couple of things here. You know, this one was done, there's no kick-out flashing here. This is what it should look like right here, especially around windows. We can see the flashing has been installed there before we actually put our stucco or EIFS to it. If we don't do it, this is the result. So we will eventually see water penetration. Most likely on the inside walls is where we'll see it. But boy, you get in here and you get this kind of moisture, you're going to have a termite issue in no time flat. So let's just look real quickly at what the framing would look like. It would be, here's the stud with the sill plate. Here's our concrete foundation. We have our sheathing on the exterior, our wafer board, our plywood. There would be that air barrier, of course, and then we would have the drive it or aqua flashing. So the flashing for our synthetic stucco, metal lath for our regular stucco, and the 2 base coats, and then of course whatever else, but most importantly, weep screed at the wall bottom. So there we are. That is a cover of our structure. And let me get Melanie to come in and tell us a little bit more, and then we'll get to the Q&A.
Hey everybody. So I'm so glad you answered the good stucco, bad stucco question that's in everybody's mind. I also had a house with asbestos siding. So if you ever have a client that's scared of that, have them call me because it'll be all good. If you have questions, put them in the Q&A and Rael will read them and answer them. I want to tell you what's next. If you liked this little tidbit of information, I have an opportunity. I'm inviting you to my house. And a week from Wednesday on September 30th, the very end of the month, we are going to do a live virtual inspection. And so I have Mark Kinsey, one of our most requested inspectors, is going to come inspect my house. I haven't been in my crawl space since I bought the house, so we will have some fun treats and fun surprises. If you have a Georgia license, it is also available for CE credit for you. So it will be 3 hours, and what I think is going to be fantastic about it is you'll be able to ask Mark questions as he's inspecting, and you won't have to worry about a client being there. And I mean, there are a lot of questions I always like to ask, but having a client there would maybe make me nervous about. That won't happen. So I'm inviting you over to come into my crawl space and all of the other exciting places in my house via Mark, who's going to inspect it. And then you'll see after the class, we will send you, when he finishes the report, I'll actually send you the report so that you can see an example of our work in progress. So if you are registered for these, I'm going to send you the link. If you want CE credit and you have a Georgia license, you'll need to send Barbara your license number. But once you've registered for this webinar, you're registered for all of them. We'll send you the link, and I'm so excited to have had you for our September series. We're going to turn it over to questions now. I want to remind you one thing I heard from a very smart person. There is no such thing as a dumb question. So Rael and I don't have jobs if you don't have questions. So that means just because Rael knows the answer like that does not mean your question is not a good question. So feel free. This is a great time to ask questions because nobody's ever going to know who you were when you asked the question, and your client will never know that you asked it, and you'll get to put the information into your brain and present it back to other people and sound like the smart one. So Rael, if you'll go to the Q&A and see what we've got.
let's just go with, how do you tell the difference between the good and the bad stucco? Okay, so we would locate a place somewhere on the home. Sometimes there will be just a little bit of that, that little mesh that we look for. We know that we're gonna have a fiberglass mesh with the EIFS, and we're gonna have a metal mesh with the stucco. So we would find a place somewhere unobtrusive that we could just barely just put a little bit of a little scrape off a little bit, and then we could seal it back up, you know, to see what kind of mesh we have. Sometimes it's just totally visible. We put our hands up underneath and you can feel it. Some folks say that you could knock on it and you can tell. That's really not all that accurate in my estimation, simply because you know, sometimes you could have, you could be tapping on it right where there's a stud, and that would give you that kind of a thud sound that wouldn't be real hollow. The difference is the hollow sound versus that heavy thud. So that's just basically comes with having a lot of experience on doing this. Those are the two ways that we could tell between the two. And also pretty much every home that has the hard cut stucco will have a crack or so somewhere. It's the difference is, you know, really why did stucco become such a big thing for us all of a sudden? Well, you know, the Europeans have been doing stucco for decades, but the difference between their structure and our structure is that their base structure of their walls is also stone, brick, and solid, versus ours is wood frame. So ours our homes tend to move even with heavy wind and stuff, and because of that movement, that cement-based stucco is going to crack, and that's why we can see them so much here. There's actually a house out in Cobb County that's part of one of our classes that is, the walls are about 14 inches thick, and was built in the late 1800s, and that thing doesn't have a crack on it at all. So that's the difference. It's how the house is actually, the bones of that house is actually set up and compared to what we have today. So how problematic is the bad stucco? Again, it all comes down just to the installation. If it's kept out of the ground, as is the same with the hard coat, it's not an issue. If you have your drip screed on the bottom, you maintain your caulking around your windows and doors, and you have your flashings in place, it's a wonderful product. Mine's been on for 25 years now, no issues, knock on wood. But it's really, it's a terrific product. I would recommend it as the next thing after brick as far as an insulation product goes. You know, certainly now with our hardy plank, that's also a great product. But yeah, when it comes to the stucco itself, I'm really happy with my EIFS. Okay. There was also a question about, could a sealant be applied along the area to protect it? I was thinking, hey, Wendy. Yeah, it's again, it's just a matter of our homes need constant maintenance. And if we could just take even something like a walk around the home to carefully look at our home twice a year, that would be great. But, you know, we're all busy. We're all running here, there, and everywhere. So folks don't take the time. Fact is, you know, perhaps your little sign comes up in your car that says that you need an oil change. So you go in and have it done, or else you just keep on driving. So change your tires, change your oil. Let's take a walk around our house every couple of years. Make sure that our caulking's in place, making sure that our downspouts are still connected to the extensions, things like that. It's all things that should be done on a regular basis. I think we've covered, oh, we have a couple more. Is the concrete slide, in the concrete foundation slide, you referred to efflorescence? Not sure of the spelling. This is a moisture indication in the foundation concrete pour. Yeah, Dana, basically what's happened then is they've poured it, and there is some kind of way that it's intruding. There's probably even, hardly even visible, might be just a very, very minor crack that comes through there. And fortunately, it's just a very easy fix to be done with the sealant that we saw earlier. So yeah, it is an indication of of moisture in there. You see it, of course, a whole lot more on our masonry block foundation than we do on the poured concrete foundation. Do you recommend pressure washing to IFS stucco? Yeah, I mean, it can be done, but you don't want it to be, you want to have not just the neighborhood kid that has a pressure washing machine to come out and attack your house with that. They will knock a hole into that stuff as they would with a hard coat. You really need to have it done correctly. There are certain types of soap products that can be added to the water. It doesn't have to be done at a high pressure. It can be done at a medium to lower pressure done. But the soap products can be, certainly environmentally, good. We don't want stuff sprayed onto the house and run off and then kill all the shrubs either. So don't spend $100 with the local guy from the neighborhood who's not on the football team today, but he's going to go ahead and do a couple of these homes for his, to use up his pressure washer. Get a qualified guy to come in and do it for you. Wendy had a question about where the two different cement pours come together. I'm not sure if that was a question, but we covered that in how it is actually done, where those weak spots or possible entry points for moisture might be coming in. So it could happen with two things. It could either be with some settling where we see the crack, or if the pores were done and it hadn't sealed up correctly all the way through. I think that covered it. Unless there's somebody else who wants to jump in and ask one more, we're pretty much done.
No, thank you so much, everyone. We'll send you the recordings and look forward to seeing you next Thursday, where I don't remember what we're doing next Thursday, Rael, do you?
I think it might be plumbing, or it might be the exterior. We're doing exterior stuff. So we'll probably see some more of the stucco and asbestos and all that kind of stuff there as well, but that'll be it.
Very good. So we'll see y'all next week, and then be sure and put on your calendars September 30th, 10 to 1. Come to my house and see all of my technical glory. Thanks everybody for coming.
And being that we'll be at Melanie's house, be sure to wear a mask and social distance. Take care, guys. Thank you. Bye-bye.